Hello everyone, this is Ujjwal Kumar. So this is my lab experiment number 3 for the uh, for the Unix lab, like experiment number 8. So we are going to see process creation in this video. So in this video we have to write a C++ program to create the following process. So A will be the parent and B will be the child. So the major requirement for this program will be process A gets second as input from the user. Process B calculate hour, minute and second and print in hour, minute and second format. Then print the process ID and parent process ID of each process. So let's go to the demonstration part here. So we have a file with name vi-basic.cpp. If you see here, uh, we have first we have included some library file. Okay, so has include system types.h is the required library file, and then IO stream will be the required library file. Okay, if you see here, we have a PID uh, underscore T, then PID. So PID is of data type PID underscore T. Then we have three variables: second, hour, and minute. So user is asked to enter the second. So enter second, since scene second will be taken, then PID equal to 4. So it means that we are creating a process here. If PID equal to 0, it means that we are going to the child process. So C of process P, if second greater than equal to 60, what we'll do, minute equal to second divided by 60 and second equal to second modulus 60. So from here we are getting the second exact value, and if again minute is greater than equal to 60, what we'll do, we will do hour equal to minute by 60 and minute equal to minute modulus 60. Then we are printing cout hour, cout minute and cout second. Then the process ID of get PID will print the process ID of a child, and get PPID will print the process ID of the parent ID. In the end, if you see, we'll just calling this slip system call for 1 second, and process A, process ID and parent ID will be printed. So let's go for the demonstration of this program. So this is a C program, that's why we are using G++. Yeah, if you see here dot slash a dot out, now user is entering the value in the second. So if we enter 3 6 7 8 9, so it will print 1 hour 1 minute 19 seconds. Process ID 29620, and if you see here parent ID is 2961. Here is process is parent ID, so this both are having the same process. It means that process A is the parent of the process P. So in the next program, what we are going to see, we are going to see a C++ program to create the A having a two child B and C. Process A reads string as input in character. Process B reverses the string and displays. Process C checks the string for palindrome. Then the process ID in each process. So this is also a simple program. We are just going to experiment 2. Yeah. So in this program also we have included some library file, and then we have C and D as an array of character data type, then K and flag are the variable of int data type. Then user is asked to enter character one by one and end with character E. So what he is asking now, enter character one by one and end with the character E. So at the end we have to type E, while one Cn C of n. If Cn equal to E, then we have to break the loop, else we'll n plus plus. Now we have int m equal to n minus 1, cout the PID T, PID 1, PID equal to 4. So see here, first child is created. So PID equal to 0, it means that child B process ID get PID we are printing. And for int I equal to n minus 1, I greater than equal to 0, I minus, then we are copying the content of the C array to D array, and then reverse string. So we are reversing the string, then we are cout D, cout n plus plus, then else sleep for 5 seconds. In parent process A process ID we are printing. Then again, if you see here, PID equal to 1 equal to 4, it means that we are getting again a child. So this time process C will be created with the same ID and I equal to 0. If C of I not equal to C of m, it means flag equal to 0 and break m minus. If flag equal to 1 is yes, it's a palindrome. because we are reversing this string and the same time we are checking it also, else it will print it's not a palindrome. So let's go for the demonstration part of the program. Here if you see here, enter character one by one and end with character E. So hello, so child B process ID is printed, reverse string is also printed. Yeah, so yes, palindrome is printed here. So for this is all about this program. Let's go for the next program. We have write a C++ program for the following process. So A is having two child B and C, then B is having one child, C is having two child E and F. So process A reads as an integer input, process B find the factorial of the number, process C checks the abstract or not, process D find the Fibonacci series, E check the prime or not, F the first, and then we have to print the process ID. So let's go for the demonstration part here. So we have file with name experiment3.cpp here. So this is also the actually same. We have one variable with name factorial, one with name power. So this is the function int comma I, and this is the function int comma int. Then we have main function. We have already declared two functions, that is factorial and power. Now we have a variable data type temp number semicolon 0 a equal to 0 remainder. Then enter the number will be entered and number will be taken, and the number is transferred to temporary variable. Then PID T, PID 1 2 3 4 5 everything will be there. PID equal to 4 will be creating the first child process. The process B process ID get PID we are printing, and we are finding the factorial with F equal to factorial number. And then PID 2 equal to 4 process D will be created, then T equal to 1 T equal to 2 equal to next term will be there, then we are printing the Fibonacci series here, then print the first two term, then next two term, and some adding two term we are printing the Fibonacci. And for the remaining, for where the process CID, in this we are just checking the Armstrong number or not, so that's why using the power function here that we have already declared. And if sum equal to number, then we will say okay, this is Armstrong number, or else it's not Armstrong number. And process is finding the smallest prime number is 2, then we are checking this prime number or not. So we are running the loop from that prime number to greater than number 2 to less than that number. If any number gets divisible by that number, it means that it's not a prime number, else it's a prime number. Then process 4 will just what it will do, it will reverse a number and it will print a number. This is simple program, and the last program will just print a factorial value. So this is the programming part. Let's see the working of this program. Yeah, we are asked to enter the number here, so we are entering the number as 12. So process B will be printing factorial now. Process B ID 5, so we will not say it's not Armstrong number, that we know it's not a prime number. Reverse number is 21. So this is all about this part. Thank you for watching.